Today we're going to look at lesson 8-5 again, but this time what we're going to focus in on is something called factoring by grouping. Oh, sorry, I forgot the word by. And today's date is the 15th. Now this to me is kind of like a little bit of magic that we can use. Now, we had talked yesterday about factoring out a GCMF, and the GCMF was an M. It was a monomial, and that's what we pulled out. And so that's something, no matter what type of factoring problem we have, it's always the first thing that we look for. Is there something all of the terms have in common? If so, I have to take out that GCMF. Once the GCMF is out, then I look at what that remainder polynomial is, and I see if I can factor it. So always look for a GCMF. That's always, always, always number one. But today what we're going to talk about is what if what they have in common isn't a monomial, but what if what they have in common is a binomial? So the greatest common factor could be binomials, and that's what we're going to see today. So factoring by grouping is a strategy that works under certain conditions. So we're going to write down those conditions. Conditions to use this strategy. Number one, 4 or more terms. Honestly, at your level, you will see no more than 4 terms. Okay? So that's how this factoring by grouping can only work if you have 4 or more terms. Terms have common factors and can be grouped together. Now, while I can envision there being 5 terms or 6 terms and being able to group them in groups of 3, that is not going to be the case for us. Okay, that's probably Algebra 2 trig. You may see something like that. So ours are going to be 4 terms, and what we're going to look for is grouping them predominantly in groups of 2. There are some rare occasions where you're going to split them up into a group of 3 and a singleton, okay? But that doesn't occur as often. So that is for us, we're going to be, generally speaking, taking these 4 terms and grouping them in pairs, okay? And then as you factor out the GCMF for each pair, a common binomial reveals itself. So, if these conditions are not met, then it is possible that you may not be able to factor this particular polynomial. And when a polynomial is not factorable, we call it prime. And that's when a polynomial is not factorable. Now here's where I get worried when I introduce this term. I will give a quiz or a test, and I will have students tell me that 5 out of 8 of the questions are prime. And I'm going to guarantee you, if I make a test, the majority of them are going to be factorable, okay? Because I want you to practice that skill. So if you keep thinking, oh, it's prime, it's prime, it's prime, you're missing something. Something isn't showing up that you aren't, and you're not seeing it. So when a polynomial is not factorable, okay? So there's times when you have a binomial and there's no GCMF, and that's it. It's not any other kind of special binomial, and you can't factor it. And so that might be prime, okay? There may be a time when we can't figure out how to group the 4 terms in pairs to find something, and when we pull out each common factor, then there's this common binomial. So we could have a prime one, but it doesn't occur very often. In fact, let's see if there's any that show up on your homework. Not a 1. Okay, so everything is factorable on your homework. Okay, so just keep that in mind. Okay, so let's see what it looks like, and let's kind of test it out. So we've got this guy, 4QR plus 8R plus 3Q plus 6. Now, in my experience, often the way that the problem is written, that the first 2 monomials have something in common and the second 2 have something in common. Sometimes all that a pair have in common is 1. That's okay. You can rearrange the terms to have them have something in common. But what I'd like you to try is, can I find something in common with the first 2 and the last 2? So let's look at that. What do 4QR and 8R have in common? 4R. So if I pull out the 4R, oh, here we go. We get Q minus 2. Oh, sorry, Q plus 2. And then let's look over here. And what do the 3Q and the 6 have in common? 3. Now here's what's important. Put the sign in. They have a positive 3 in common. Very important that you do that. And then 3Q divided by 3 is Q, and 6 divided by 3 is 2. And then there's a miracle. Look at the binomial. Q plus 2, Q plus 2. Magic. Okay? So what we can do now is pull out that common factor. So we're going to pull out the Q plus 2. So we have Q plus 2. And what do you think happens over here? Well, what's 4R times Q plus 2 divided by Q plus 2? 4R. What's 3 times Q plus 2 divided by Q plus 2? 3, but it's not just 3, it's positive 3. And ladies and gentlemen, you have just factored a 4-term polynomial. That's what factoring by grouping is, okay? So what we're going to do is work through a couple different problems, because I want you to see there's all sorts of issues that crop up. So we're going to practice all sorts of different things. Yes?
Wait, so if the Q plus 2 and the Q plus 2, if one of them wasn't Q plus 2, so they'd be different, they'd be prime?
Yes. But here's the problem. Kids will think that, but what happens sometimes is that, let's say, a negative didn't get pulled out appropriately, and it looks like they're different, but in reality, mathematically, they should have been the same. So that's what you are going to have to be really cautious with. So we're going to practice through some problems where we have signs, and we have to pay attention to those, okay? But yes, if you pull out the common factor for each pair, and what's left behind in the parentheses doesn't match, it could be prime. Now, what you might end up doing is trying the problem again, rearranging the terms. And then it may work out better with the terms rearranged, okay? Brandon? You're good? Okay. So that's our process. So we're going to, let's just write it down in words. Step 1, we group terms in pairs. We then factor out the GCMF for each pair. And I'm going to write here a note. Include the sign of the second, oh, sorry, that's not, hello, I said sign and wrote second. Hello. The sign of the second GCMF. That's really important. That's probably one of the most common mistakes is kids have They don't put the sign on that second GCMF, and then they don't know what to do, okay? But you got to pull out. It's either a plus or it's a minus. Factor out GCMF for each pair. If the remainder polynomials match, which is our magic, so I say polynomials, but in our case, it's going to be a binomial. Factor that binomial out. And the two GCMFs form their own binomial. So we should end up with minimally binomial times a binomial. Okay, there's other things that could occur that would make our answer longer. Now, I should say we have something in the top here. Because this is so ingrained in me, I forget to write it as a step because it's just what I naturally look for. You always begin with look for a GCMF for all the terms first. Okay. Now, how do you know if you're right? Brandon?
Multiply it out.
Yeah. So let's go back to that problem. What I'm going to do is just distribute out to see if I did it correctly. So I've got Q times 4R is 4QR. Q times 3 is 3Q. 2 times 4R is 8R. 2 times 3 is 6. Does it matter if the order is different? No, because, yeah. We have the commutative property of addition says the order that you add is not going to change the meaning behind the answer. So that just verifies, yeah, I did it right. Okay. All right, so let's go launch into a couple. And you're going to see different cases, so different things that you will have to consider. This is something you do actually need to spend time thinking about. So don't go rushing through this. So directions we're going to say is factor. I think, what does your book say? No, this one finally gets to just the word factor. Factor each polynomial. Okay, so let's do Rn plus 5n minus r minus 5. So we're going to try to group them 2 by 2. So we'll group these two. Do those two have something in common? What do they have? They have an n. Okay, what about this 2? Yes, and that's really important. If your front term in the second grouping is negative, you have to pull out a negative. Okay, so keep that in mind. And then beyond that, all they had was a 1. Okay, so I factor the first group, and I get n times the quantity r plus 5. Well, actually, let me do that different color. R plus 5. And then we're going to factor out a negative 1. So negative r divided by negative 1 is r. Negative 5 divided by negative 1 is positive 5. So did we get our miracle? Yes, we did. So we factor out the r plus 5, and left behind is the binomial that contains n minus 1. Yeah, this is, you just need to kind of get used to it. And again, we're going to use this strategy with other types of factoring. Yes?
I just didn't know that how to find like the last step to get the r plus 5 and the n minus 1, but then I see it's just what's left of that.
Exactly. So these are forming your second binomial. Okay? All right, let's try another one. So let's do 2mk minus 12m plus 42 minus 7k. So we're going to try grouping them by 2s. So what do 2mk and 12m have in common? They have a 2m. And what do 42 and negative 7k have in common? A 7, right? So I get 2m times, and then let's see, 2mk divided by 2m is k, and then minus 12m divided by 2m is 6. And then over here, oh, by the way, that's a positive 7, so I'm going to pull out a positive 7, and left behind is going to be a 42 divided by 7 is 6, and then it says negative 7k divided by 7 is negative k. Did we get our match? No. Okay. But what do we call these two terms? Okay. They're opposites. Okay, so my question is, before you say, okay, it's prime, we can't do anything, is there a way to make those two binomials look the same? Michael, eh?
Would the first step be like dividing by negative 1?
Okay. So what we could do is pull out a negative 1, and this would become a negative 6, and the k would become positive. Okay. Now, the question is, what happens to that negative? Well, it comes up here. So now your problem looks like this. 2m times the quantity k minus 6 minus 7 times the quantity k minus 6. We do have our miracle where they both have the k minus 6. So that comes out in front. And now what's left behind is the coefficients. So this and this. And they form their own binomial. So we get 2m minus 7. So that's my caution regarding this notion of prime. If the two binomials do not match, ask yourself, is there something mathematically I can do to get them to match? Okay? But you're going to have to contend if you're pulling out a sign, and this is typically what it would be, is just pulling out a negative. Then you would end up changing the sign of your second grouping, or whoever you switch it around for. Sure, we'll do another one like it. Okay, so that's that answer. And again, you can FOIL it out to make sure, FOIL it out, see, I'm so used to saying that. Distribute it out, or however you like to solve it. All right, let's do another one. Let's do it. C minus 2CD plus 8D minus 4. So we're going to look at the first two. What did C and negative 2CD have in common? A C. So if I factor out the C on that one, that gives me 1 minus 2D. Okay? And then what do they have in common in the second grouping? A positive 4. So if I factor out the positive 4, see, 8D divided by 4 is 2D, and negative 4 divided by 4 is negative 1. So when you see the same terms but with opposite signs, that's when we can use this idea. Now, it is true that I could take either one of those binomials and factor out a negative. Okay? However, it's usually best to take it out of the second one. All right? So I want these terms to rearrange. In other words, I want the 1 to be positive and the 2D to be negative. So if I factor out a negative 1, that positive becomes a negative, and that negative becomes a positive. And again, my whole point is to rearrange the terms so it looks exactly the same as the first pairing. Now, I have to take this, and I put it up here. So now your factoring looks like this. C times the quantity, 1 minus 2D, minus 4 times the quantity, 1 minus 2D. We have an exact match with those two, so that's what is divided out. And what's left behind are the coefficients, C minus 4. and that's your answer. Okay? Let's do another one of those. Now, can somebody see something that we might think about doing to prevent us from having to pull out that negative? So is there something we could do before we start factoring? If we notice what's going to happen, or even after we start factoring the first one. Michael A.?
You could change the order of them.
Okay. So look what happens. Notice here I have a C and I have a 2CD. So C's are in front, D's are in back. But in this second grouping, the D is in front. So what I could do is just rearrange the terms, knowing that I need the D to be in back. And then when I factor, these still have the C in common, which leaves behind the 1 minus 2D. And now this group has a negative 4 in common. So negative divided by a negative is a positive, and 4 divided by itself is 1. And then a positive divided by a negative is a negative, and 8D divided by 4 is 2D. So if I think about, oh, wow, I need my variable to be in the back and it's in the front, we can just use the commutative property and rearrange them so that it avoids that having to pull out a negative, doing that extra step. So now we still just get the 1 minus 2D times the quantity C minus 4. Okay, so that's another idea to think about. All right, let's do a couple more.
Can you do an example of prime?
I can give you a really basic one that's prime. Okay, so the first two have a common factor of 2. So I factor out the 2, and that leaves behind x minus y. The second group also have a common factor of a positive 2. Oh, and I should have factored out a GCMF. Oh, well. That's me being bad. And we end up getting a minus b. Oh, sorry, it's 2. Yep.
And then it's 2B.
Yep. So you can see right there, we don't have a miracle, and there's no way to make the miracle happen. I mean, I don't even have the same variables. So that sometimes will happen. So that is definitely an example of something that's prime, because there's no way I can get a match. Okay? No rearranging is going to change that. And then sometimes what I'll see will be something like an answer that looks like this. Let's say we do out the factoring and we get 3 times the quantity x plus y, and then we have the factoring plus x times the quantity x minus y. So that's another one. And again, there's no way to change. There's no way I can factor out a negative and make a negative go away. Okay? So these also would never allow me to factor this further. So then we just say it's prime. Okay, if I can spell it. All right. Oh, Patrick.
Do you have any tissues?
Oh, I have boxes of them over on my bookcase there, so help yourself. All right, let's do another one that would have negatives in it, but this time let's see if we can if we can look at the problem and say, all right, I see where there could be an issue, so let's try to rearrange. Okay. So where do you want to flip?
Negative 2p squared into 3p.
Okay, so if we rearrange and write it this way. Okay, all right, let's try that. So the first two have what in common? Okay, now, here's where it gets a little bit tricky. if your leading term is negative, you got to pull out the negative. Okay? So we're going to pull out not just the p, I agree with that, but we'll also pull out a negative. Okay? So that gives us a negative p, and then what's left behind? Let's see, a 2p minus, because the signs are different, a 3. Okay? And then what am I going to pull out from this second group? A negative 9. So again, remember, anytime there's a negative in front, I got to pull out the negative. So I get negative 9, and then what's going to be left behind would be a positive 2p, excuse me, and a negative 3. So we get our match. Oops, sorry, wrong color. So they both had the 2p minus 3. So when I factor that out, I'm left behind with this. A negative p minus a 9. Now, chances are that's not an answer that you will see. Let's say it was a multiple choice test, okay? You may not see that as an answer choice because there's a factor lurking in this problem. If you look in this second binomial, there's a common factor. What do they have? A negative 1. Okay? You cannot leave any common factors in any binomial and say it's factored. Okay? You got to keep factoring. So you would pull out the negative. You still have the 2p minus 3. But now this becomes p plus 9. Now, you may not actually see that answer if it's a multiple choice test. Okay? What you might see is that they would distribute this negative into this polynomial. And the reason why they would distribute it, it's because you have different signs, so you can still have a positive term in the front of your binomial. So what would happen is that the 2p becomes negative, and the negative 3 becomes positive. And that, 9, would be your final answer. So, number 1, this is not final because of the common factor. I would take either one of these answers as being correct. But you need to be forewarned because remember, you guys are taking that placement test from the high school. And they may not offer the first answer choice. They may only offer the second answer choice. So you need to understand you have to be flexible with your answers. Okay? Does that make sense? Okay? All right. You guys feel ready? Okay. That's it.